Greetings, I am Rhea Marie F. Caballero from STEM 11 St. Boniface, and I will be discussing our reporting together with Mr. Kurt John Ares. Our topic is the conic section circle. For the contents of our presentation is the introduction, the parts of the circle, and our word problem with our solving. For our objectives in this presentation, first, we have to impart knowledge about conic section circle. Second is to let learners to be able to identify the parts of the circle. And lastly is to help the learners to solve real-life problem solvings of circles. For the introduction, a circle is a set of all points equidistant from a given point. The point from which all the points on a circle are equidistant is called the center of the circle, and the distance from the point to the circle is called the radius of the circle. For the parts of the circle, a chord is a line segment whose endpoints are on a circle. Well, a circle is a set of all points at a specific distance from a given point in 2 dimensions. While a concentric circles, it is 2 or more circles that have the same center but different radii. For the congruent circles, it is 2 or more circles with the same radius but different centers. For the diameter, it is the measure of the distance across the center of a circle. The diameter is equal to twice the measure of the radius. For the point of tangency, it is the point where the tangent line touches the circle. While the radius is the distance from the center of the circle to the edge of the circle. While the circumference is a measure of the distance around the outside edge of a circle. While a secant, it is the secant of an angle in a right triangle is a value found by dividing length of the hypotenuse by the length of the side adjacent the given angle. While the secant ratio is the reciprocal of the cosine ratio. And the tangent is the tangent of an angle in a right triangle is a value found by dividing the length of the side opposite the given angle by the length of the side adjacent to the given angle. While tangent circles are 2 or more circles that intersect at one point. This is the illustration for the circle.
So basically, a circle in pre-calculus is all points in a plane that are a fixed distance from a given point in the plane. The given point is called the center, HK, and the fixed distance is called the radius, R, of the circle. The problem is, Max has connected to a piece of Wi-Fi which has a signal service of a 3-mile radius. If we were to plot the piece of Wi-Fi on a coordinate plane, it would be at -4.5, whose units represent miles. The question is, what is the standard equation of the outer boundary of the region that has Wi-Fi connection? If Mach lives at 0.8, is he within the Wi-Fi range? We are still going to use the formula d equals square root x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, from which the center is hk for -5. And still, we are going to substitute the xy and xk to get the answer. Therefore, d equals square root 0 plus 4 squared plus 8 minus 5 squared. So the answer is d equals 5. Since 3 is less than 5, therefore Max is not within the Wi-Fi range. The question is, a particular cell phone tower is designed to service a 12-mile radius. The tower is located at -3.5 on a coordinate plane whose units represent miles. What is the standard equation of the outer boundary at the region serviced by the tower? Is a cell phone user at 80 within the service range? In getting the distance of the circle, the formula must be d equals square root x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. We can see that the center is hk, which is -3, and the x and y is 8 and 0. So all we're gonna do is we're gonna substitute the hk and xy. Therefore, after we substitute d equals square root 8 minus negative 3 squared plus 0 minus 5 squared, and then the answer is square root 146, and the square root of 146 is d equals 12.8 miles. Therefore, the cell phone user is outside the service range of the cell phone tower. Thank you.
This is the recognition for the efforts of each member for each of their contribution in this presentation. For the reporters is yours truly, Ray Emery F. Caballero and Mr. Kurt John Ares. As for the problem-solving contributors are the modular learners Neil Vincent Menos and Ralph Angelo Piscuala. And as for our assigned PowerPoint encoder is Ms. Eliza Camila Mata. Thank you so much for listening. God bless.